Hello students, I am Anup sir and today I am going to start physics and in physics we will be doing first chapter for class 10 and the first chapter is force. So before I start with the explanation of the chapter, I would suggest you all that as I give you the notes, first you make fair copy for those notes, note down all the notes in that fair copy, and then while I am explaining those notes on the board, you should have that fair copy with you, so it will become very easy for you to understand the topic. Okay, so if you see in the notes what I have given, when a force acts on a stationary rigid body which is free to move, the body starts moving in a straight path in the direction of force. This is called linear or the translational motion. Okay, for example, let us consider an object kept on the table. Okay, and this object is free to move. Now suppose a person applies force on this object in this direction. So what will be your observation? Or you think over it, you are standing over here and you are applying the force on that object which is free to move. This is an object kept on the table. So your observation will be that the body starts moving in the direction in which you have applied the force. So such type of motion in which body is free to move and when force is applied on the body and the body starts moving in the direction of the force, we called such motion as translational motion. So, or we can take an example that you are pushing a table, you stand in front of the table and you push that table. What will be your observation? The table starts to move in the direction in which you are applying the force. So we can say the motion produced in the table is translational motion. Okay. Next, now let us consider a body which is not free, or you can say it is pivoted about a point. For example, if we consider door, you must have observed doors at home. There, let us consider a door. Then what you have observed in case of a door, that these doors are fixed about the point which are called the hinges of the door. Now, when you apply force on the door, what you will observe that the door moves like this. Now, suppose this is the door and this door is fixed about the point. Now, let these two be the points where the door is fixed. You are applying the force on the handle of the door. So, what will be your observation? You will observe that this door moves like this. That means you will see that the door is having a rotational motion. So such a motion in which body is pivoted about a point, and then if we apply the force on the body, then the body starts to rotate about that point. Consider this pen. It is fixed about this point and you apply the force on this pen. You will observe that the pen rotates like this about the fixed point. So which type of motion is this? This is rotational motion. So we have two types of motion. One is the translational motion and the other one is the rotational motion. So for the translational motion, we can give an example that you are pushing a table. So that will be the example of translational motion. And the second example for the rotational, we can say a man opening a door. When you open the door, then the hinges are known as the fixed points. So about these hinges, the door will rotate. So we will say that is a rotational motion. So two types of motion, translational and rotational motion. Next we have moment of force. Now let's see what the moment of force says. Moment of force, which is also known as the turning effect of force. Here we have observed the turning effect of force in opening of a door. when we are opening a door, there we saw the turning effect of the force, which is also known as torque. So the moment of force is the physical quantity that measures the tendency of the force to rotate an object. The tendency of the force to rotate an object. So that physical quantity which measures the tendency of the force to rotate the object, that is known as moment of force. Now let us see. You consider a body like this. This body is pivoted about a point. It is pivoted about this point, which we have named as O. And we are applying the force on the body at this point. On this body at this point, we are applying the force. Now when this force will be applied on the body, this force will rotate the body, because the body is pivoted about a point. So here we will be having its axis of rotation and the body will rotate like this. So we will say that this force is producing the turning effect on the body. So how to measure the tendency of the force to produce that rotational motion? So what you will do, now the force is being applied in this direction, so extended. So this will be known as line of action of force. This will be the line of action of force. And now you will calculate the perpendicular distance of this line of action of force from the point about which the body is rotating. So the point where the body is rotating, from this point you will calculate this perpendicular distance. Let it be named as D, perpendicular distance. And the product of these two will give us the moment of force. These two. So we will say, what is the moment of force? That is the turning effect of force, also known as torque. So if you are asked what is moment of force or what is a torque, then you will be saying the moment of force is the physical quantity that measures the tendency of the force to rotate an object. It measures the tendency of the force to rotate an object. And how do we calculate moment of force? So for that, magnitude of the force that you have applied will be multiplied by the distance of line of action of force from the point where the body is rotating, this perpendicular distance. So it should be perpendicular distance, not only the distance, but it should be perpendicular distance, you can say. It's not simply the distance, but it is perpendicular distance. So this is how we calculate the moment of force. Okay, now if we ask for the unit of the force, unit of moment of force. So to write the unit, now you can see that this physical quantity torque is combination of force and distance. So you combine the unit of these two, that is Newton and Newton. So the unit of moment of force will be Newton. So is this clear? What is the moment of force? So what will you say for the moment of force? The moment of force is the physical quantity that measures the tendency of the force to rotate an object. And how do we calculate it? The force that we apply on the body is multiplied by the perpendicular distance of line of action of force from the point where the body is, about the point where the body is rotating. See here, this is the force that you have applied. This force is acting along this direction. So this is called the line of action of force. And then you will calculate this perpendicular distance from the point about which the body is rotating. This perpendicular distance is represented by D. And the product of these two will give us the moment of force. And what will be the unit for it? Newton meter. Is this clear? Okay, now turning to the next. Now as we saw over here that moment of force means the turning effect. So if you see in this diagram, the force applied can rotate the body either in clockwise direction or it can also rotate it in anti-clockwise direction. So here in this diagram, if you see, this is the point about which the body is rotating and this is the direction of the force. So you can see that this body will rotate this force will rotate the body in this direction. Like this. So this is anti-clockwise. So that means moment of force can be anti-clockwise or moment of force can be clockwise. So depending upon the direction in which it is being rotated, you see in the notes I have given you, moment of force is taken positive if its effect on the body is to turn it anti-clockwise. So that means in this case, this force is rotating the body in anti-clockwise direction, so the moment of force will be taken positive. And if the force rotates the body in clockwise direction, then it will be taken negative. So this is what moment of force is. So three things over here about the moment of force. First of all, what is the moment of force? So it is the measure to measure the tendency of force to rotate an object, and then it is the combination of force and perpendicular distance. Then we have its unit, Newton meter, and then we have, depending upon the direction of rotation, that moment of force will be taken positive or negative. If it's anti-clockwise direction, then it will be taken positive as I have shown in the diagram, and if it is clockwise rotation, then it will be taken negative. Now let us consider a few examples. One example we have already done, that is opening and closing of a door. When you open or close a door, you apply the force, and then the combination of the force applied and its distance from the axis of rotation, that gives you the torque or the moment of force, or you can say the turning effect of the force. Similarly, when you are opening a nut with the help of a spanner, then also moment of force, that is torque, is required. See, let us take an example here of opening of a door first. Let us consider a door like this. It is fixed about the hinges. Now when you are opening or closing the door, suppose you are opening the door, so your door will be taken like this now. So you can see when you apply the force, then the door has moved like this, or you are closing the door, you can say. So you are applying the force in this direction. And this is the point about which the door is rotating. So you can say this is the axis of rotation. This is the axis of rotation. See, the point about which the door is rotating, at that point we have drawn the axis, so there will be the axis of rotation. Now I am applying the force in this direction at the edge of the door. Now here is the handle of the door. and applying the force on the handle. So this will be the direction of force. So the direction in which the force is being applied, that will be the line of action of force. So what we will do, we will take the perpendicular distance. We are going to take this perpendicular distance. And now the product of the force and the distance from the axis of rotation, these two will give you the moment, or you can say the torque required to open the door or close the door. Now let us see in this example only. Let this be the another diagram for the door. This be the hinges about which this door will rotate. Okay. Now suppose opening of this door depends upon the torque, and the torque required over here is suppose the torque required is 150 dyne centimeter. I've taken unit in CGS. Torque required is 150. Dyne is the unit for force. Centimeter is the unit for distance. Dyne centimeter. Now there are 3 persons who want to open this door. Okay. Let the width of this door. Let the width of the door be 30 centimeter. Width Let the width of the door be 30 centimeter. Now there are 3 persons who want to open this door by applying the force. Okay. The first person, A, applies the force at this point. Second person, B, applies the force at this point, and C applies the force at this point. Right? Now the first person now you can see in this diagram, person A is applying the force at the edge of the door. That means he is taking the maximum distance of the line of action of force from the axis of rotation. So let us see how much force that person has to apply. And the torque is 150. Because the minimum torque required to open the door is 150. That means each person has to apply the minimum torque of 150. So for A, torque required is 150. We are calculating the force applied by A into distance. Now A is applying the force at a distance of 30 centimeter. So the force So A has to apply force of 5 dyne. Now let us similarly do for B. Torque 150. Because the minimum torque required is 150. So each has to apply the minimum torque 150. Now force that B has to apply, and he is applying the force at a distance of 20. So the force that B requires is 7.5 dyne. Now C is at a distance of 10. So here we see that each of them, A, B and C, they are opening the same door, but they are applying the force at the different distance from the axis of rotation. A is using the maximum distance and he has to apply force of 5 dyne. B is using the force at a distance of 20, so he has to apply force of 7.5 dyne, and C takes the minimum distance and he has to apply maximum force. So from this example it is clear to us that the torque required is same for all, but they are applying the force at the different distance. So the one who takes the maximum distance has to apply the least force. See A, example for A. A is taking the maximum distance, so he has to apply the least force. Whereas B and C, they are taking distance less than A, so they are applying more force. C takes the minimum distance, so he has to apply the maximum force. So from this point, it is clear that torque or the moment of force is the combination of force and distance. More the distance, less will be the force required. That is why you will observe in all the objects where there is a circular motion about the fixed point, force is always applied from the maximum distance, so that the least force is required. Now, as in the notes I have given to you, few questions. Why is it easier to open a door by applying the force at the free end of it? You must have observed at your home that the handle of the door is always put at the edge, never in between. Because when we put the handle at the edge, we get the maximum distance and then we have to apply the least force. Same is the case of using a spanner. When we open a nut, you open a nut, with the help of a spanner, then you must have observed this is the point about which this nut will rotate, and at the edge of the handle you apply the force. So again, if more the length of the handle, that means distance is maximum, so the force applied will be least. So here I have given the few examples, and in all the examples same is the reason. Like the example is, why is it easier to open a door by applying the force at the free end of it? The handle of a hand flour grinder is provided near its rim. Again, if you are providing, now it's a hand flour grinder like this. It's a circular like this, and at the center it rotates about this point. So you will be always observing that the handle of the hand flour grinder is always at the rim edge. Why? Because if you put the handle at the edge, distance is maximum. So maximum distance, so least will be the force required to rotate it. A spanner has a long handle here. Spanner has a long handle, because if handle is long, so we increase the distance, so the force required will be less. Then a jack screw is provided with a long arm. Again the same reason, if the arm is long, you have to apply the force at the maximum distance, so the force required will be least. So here is the answer given to you. Above examples can be explained by the fact that turning of a body about an axis depends not only on the magnitude of force, but it also depends upon the perpendicular distance. That means the torque required depends upon force and distance. So if you keep this distance maximum, then the force required will be minimum. You keep this distance maximum, so the force required will be minimum. So this is the reason that all these things have the same reason. That's I've given you in the notes, you can go through it. Okay, the next topic we have is the couple. Next topic that we have is couple. Now let's see what couple is. Let us consider a body which is acted upon by two forces. Case 1. And see, in case 1, these are the two equal opposite forces. In case 1, two equal opposite forces, and in case 2, again two equal opposite forces. Now in case 1, these two forces which are equal in magnitude, opposite in direction, they are having the same line of action. They are having the same line of action. So these two forces will cancel each other. And we will say that the net force on this body will be 0. Now consider these two forces. Again, two forces are equal, opposite, but they do not have the same line of action. They have the different line of action. So whenever two forces, equal opposite forces but not having the same line of action, they act on a body, we say that they form a couple. So here we can say that these two forces are forming a couple. So here they have, now when this couple will act on the body, then this couple will rotate the body. Now here, after application of the force, you will find this body like this. This force has made the body rotate here. These two forces have made the body rotate about this point. So we will say a couple is acting on the body. This force trying to rotate the body in this direction, this force trying to rotate the body in that direction. So altogether, again you can see a couple is acting on the body, and what is the effect of the couple on the body? It is rotating the body. And in which direction you can see in the diagram? It is anti-clockwise direction. So here we can say that in the notes it's given two equal and opposite parallel forces not acting along the same line form a couple. So in the first diagram we had two equal opposite forces, but they were acting along the same line. So this cannot be a couple. But in this diagram, two forces equal opposite but not having the same line of action. So they are forming a couple. So this is a couple. And couple always rotates the body. So we say a couple is always needed to produce a rotation. Examples: when we open a door, turning a water tap, turning the key in the hole of a lock, turning steering wheel of a car. All these are the examples of couple. But now you may ask the question that where was there a couple when we were opening the door? Because we were applying only one force. Whereas in here I have told you, when two forces act on the body, they rotate. So couple is always required to rotate a body. Now a question will arise in your mind that when we are opening the door, we are applying only one force. Where is the second force? And as here we have given the example that opening of a door is the example of a couple. So what happens over there? One force you are applying, that is the external force, and the point about which the body is rotating, at that point there will be a reactionary force, and that reaction force will be in opposite in direction, and it will be not having the same line of action as the external force applied. So we can say again in that case, two forces are acting, not having the same line of action. So we can say a couple is acting over there, opening of a door. One force that you apply at the handle, and the second force is the internal force which is produced at the point where the door rotates. So again we get the two forces opposite in direction, and they together form a couple, and we say that the door rotates. Okay, next we have the moment of couple. Now let's see what is the moment of couple. What is the moment of couple? Now to understand the moment of couple, again we will draw a diagram to show a couple acting on the body. Let this be a body. At this point A, we are applying the force. At the other point B, we are applying a force. So you can see a couple is acting on the body. You can see two forces, equal forces, equal in magnitude but opposite in direction, and not having the same line of action. Now this is the line of action for the first force, this is the line of action for the second force. So they are not having the same line of action. So we can say in this diagram we have shown a couple acting on the body. Okay, now let this point be O, about which the body will rotate. Now here you can see that two forces are acting on the body, and they are not having the same line of direction. So let us find the torque, that is the moment of force produced by F at A. Now this is the point where the body is rotating. Okay. Now whenever we have to calculate the moment of a force, how do we calculate the moment of force? We multiply the force applied and its perpendicular distance from the point of rotation. Now here this is the point of rotation about which the body is rotating. So for the first force, distance from the point of rotation to the axis of, this is the axis of rotation and this is the line of action of force. So this is the perpendicular distance AO. So you can write it like this, F into AO. Now this is the moment of force F at A. Now writing just the combination of force and the distance does not give the complete answer. If you see, the force acting at F is rotating the body about O, and in which direction is it rotating it? Anti-clockwise. So we can say this will be anti-clockwise movement. I'm writing in short, anti-clockwise movement. Now this force is also producing moment. So we are going to calculate moment of force of F at B. We are going to calculate the moment of force F at B. Force applied is same F, and its distance from the point of rotation, this distance is OB. And if you see, this force was producing anti-clockwise, this force is also producing anti-clockwise movement. Now these two moments are in the same direction, so the resultant will be added up. So total moment. And now we will say this is not the total moment of force. These two forces together, they were forming a couple. So we will say total moment of couple. That will be F into AO plus F into OB. Taking F common, AO plus OB. That gives you F into AB. And AB, if you see in the diagram, it is the distance between the two forces. And the distance between the two forces in case of a couple is known as couple arm. This distance is called couple arm. So what formula we get? F into couple arm. This is the formula for calculating moment of couple. So we have derived the formula for moment of couple. So moment of couple formula is F into couple arm. And if you have to write for the unit, force is in Newton. Couple arm means the distance between the two forces. It will be in meter. So unit, SI unit will be Newton meter. So is it clear? What is couple? When two equal forces, opposite forces act on a body not having the same line of action, they form a couple. And how do we calculate the moment of couple? Because couple also produces rotational motion. So how do we calculate moment of couple? So to calculate the moment of couple, see, we have the derivation, and the derivation gives us that you have to find the product of one of the force, because both the forces are equal. So you will consider one of the force multiplied by distance between the two forces, that is couple arm. So this is the formula for calculating moment of couple. Next, in the notes I have given you equilibrium of bodies. What is the equilibrium of bodies? Now, when number of forces act on a body and they are not able to produce any change in the state of rest of the body or any change in its state of motion, we say that the body is in equilibrium. Remember, a body at rest can be in equilibrium. A body which is in motion, that body can also be in equilibrium. So that means we have two types of equilibrium. One for the body which are at rest, that is called the static equilibrium, and one for the bodies which are in motion, and that is dynamic equilibrium. So two types of equilibrium. Now, example for static equilibrium. A book lying on a table. a book is lying on the table. Now the book is at rest, and we will say that it is representing a static equilibrium. Now, how does it represent the static equilibrium? See, equilibrium means there should be at least two or more than two forces acting on the body, and then under the action of those forces, the body remains in equilibrium. So here we will say, see, one is the weight of the body, which is acting in the downward direction, and one is the reactionary force, which is acting in the upward direction. So how many forces are there acting on the body? Weight and the reactionary force. That means two forces are acting on the body. Now, under the action of these two forces, still the book that was at rest remains at rest. So that means we can say that the book is in static equilibrium. Now, dynamic equilibrium. For dynamic equilibrium, we consider the example of a raindrop. Now, a raindrop, when moves towards the earth's surface, it is in motion. And we say that it moves under the action of three forces, but it moves with a constant velocity. Raindrop moving towards the earth's surface is moving with a constant velocity under the action of three forces. Now see, three forces are acting on the raindrop, but these three forces are not able to produce any change in its state of motion. So we can say that the falling raindrop is having dynamic equilibrium. See, the three forces acting on the raindrop. This is considered a raindrop. So one is its weight, which acts in the downward direction. One is the upthrust. And the other one is the frictional force. So the frictional force of air. So altogether we can say, or you can say the frictional force of viscosity. There are three forces acting on the body: weight, upthrust and frictional force. But under the action of these three forces, still the raindrop is moving with a constant velocity. Means there is no change in its state of motion. So we can say that the raindrop is in dynamic equilibrium. So we have two types of equilibrium. I am giving the examples, and in the notes I am giving you. Then we have conditions for equilibrium. What are the conditions for a body to be in equilibrium? There are the two conditions. See, the first condition I have given is the resultant of all the forces acting on the body should be zero. Resultant of all the forces acting on the body should be zero. That means you can write like this: summation F is equal to 0. Summation F here means sum of all the forces acting on the body should be 0. That's one. Second one is the algebraic sum of the moment of all the forces acting on the body about the point of rotation should be 0. F into D, that is the moment of force, and we are taking summation, that is the algebraic sum of all the moments of the forces acting on the body about the point should be 0. So these are the two conditions which will be fulfilled, then we can say that the body will be in equilibrium. Now we have the topic principle of moment. Now the principle of moment says if a body is in equilibrium, then the sum of the clockwise moment acting on the body will be equal to sum of anti-clockwise moment. Now let's Understand it through this diagram. Now in this diagram we have shown a body is in equilibrium under the action of 1, 2 and 3 forces. And now let us derive the principle of moments from here. Now suppose the body is in equilibrium. Now if the body is in equilibrium, then sum of the anti-clockwise movement will be equal to sum of clockwise movement. Now there are three forces F1, F2 and D3. Sorry, F3. These three forces are trying to rotate the body about the point O. Distance of the first force is D1, distance of second force is D2 and distance of third force is D3. And these three forces are trying to rotate the body. Okay. Now what we will do, we will calculate moment produced by these forces. So let us calculate moment of F1 about O. This is the point of rotation. So formula is F force applied F1 into its distance. So you can see the distance of this force F1 from the point of rotation is D1. And you can see this force F1 is trying to rotate the body. In which direction it is trying to rotate? F1 is trying to rotate the body in anti-clockwise direction. Similarly, if you consider F2, F2 is also trying to rotate it in anti-clockwise direction. F3, if considered, you can see it is trying to rotate the body about O in clockwise direction. So we can say in this figure, these two forces F1 and F2 trying to rotate the body in anti-clockwise direction, whereas F3 is trying to rotate the body in clockwise direction. So moment of F1 about O will be F1 D1 and its direction will be anti-clockwise. Moment of F2 about O, this is the axis of rotation, F2 into D2 and again its direction is anti-clockwise. Now this force F3, its distance is D3 and it is trying to rotate the body in clockwise direction. So we have calculated moment of F1, moment of F2 and moment of F3. Two are anti-clockwise and one is clockwise. So by the principle of moment, we know that sum of anti-clockwise moment, now body is in equilibrium. So in equilibrium, sum of anti-clockwise moment clockwise moment. So here sum of anti-clockwise moment. So these two moments are anti-clockwise. So we are going to sum them. So F1 D1 plus F2 D2 is equal to sum of clockwise. There is only one clockwise. Anti-clockwise were two, so we added them. Clockwise is only one. And by the principle, we know that in equilibrium, sum of anti-clockwise moment is equal to sum of clockwise moment. So we are going to equate it this way. So remember, whenever a body is in equilibrium, then the sum of anti-clockwise moment will always be taken equal to sum of clockwise moment. This is called the principle of moments. And then we have given you an example which works on this principle of moments, and we have given you a physical balance, or you can also call it as a beam balance. that works on the principle of moments. So, in this topic, we are going to do up here, and in the next session, we will continue with the same chapter. So, till then, first of all, again I am telling you, you make your notes copy. First of all, note down all the notes that I am going to give you. And then when you are going through the explanation, you should have your notes copy with you, so that you will read the topic and then see the explanation of it. You pause the video, again read the note, and again see its explanation. In this way, it will be very easy for you to understand the topic. So, till then, just keep in touch with your studies and be safe.